Welcome to Unit 4. In this unit we're going to continue our coverage of conventional energy sources, in this case oil and natural gas. We're going to begin by looking at how oil and natural gas are formed and where they are deposited. So remember, oil comes from petroleum, and petroleum comes from ancient living organic organisms which are buried and then due to high temperature and pressure are transformed into oil, gas, and tar. You might have noticed when you're making salad dressing or in other sorts of activities that oil is lighter than water. It floats, and therefore it tries to rise to the surface unless it's trapped. There are three different types of traps. There are anticlines, faults, and unconformities. As you can see in these images, an anticline looks like it's trapped at the bottom of a hill, or under the top of a hill, I guess is the better way of saying that. A fault occurs when one plate or one set of rock structure strata shift relative to the other, creating an area where the oil can be contained. And lastly, in a fault trap, in the past the strata went one direction, then there was a change, and the strata above go a different direction. What you get, oil versus natural gas, depends on how it is formed. So to get natural gas, you need water, nutrients, and no oxygen. But to get thermogenic gas and crude oil, I guess it's biogenic gas, not one type of natural gas versus a different type of natural gas, and crude oil, you need heat, water, and no oxygen. So if you go drilling for oil today, what happens? You have to find an underground reservoir. That reservoir is tiny cracks and pores in the rock. It's difficult to extract. It's nice to think about, basically an open pit underneath the ground that is just full of oil you can suck out, but that's not what this is. What we actually have are crevices within the rock, right? We have found the easy stuff. That's been used or is in the process of being used. So currently we're having to go look deeper and farther for oil. That leads us to things like ultra deep wells, which are under 3,000 meters of water, and then or depths of 12,400 meters on land. We can also do horizontal drilling, but that requires more wells. Here is a schematic. The little gray squares here are the oil wells. This is a disposal well. So the idea is you draw something up through the oil well. What you don't need is put back underground through the disposal well. Depending on the size of the well and the richness of the well determines what size of well or you get. Here, notice, is an anticline. This would be a fault, and it's not clear what type of trap these would be. Here are different ways you can put the wells in. You can do sidetracking, where you have one initial well and then you branch to hit different parts of the reservoir. You can have salt dome drilling, where you have different wells reaching different portions of the reservoir. You have fault controlling, where you have one well designed to pull the oil out and another well which holds the fault steady. And when you have a well that is, say, located underneath a city, you can bring the well in, or when you have a reservoir located underneath a city, you can bring the well in from the side. So you drill down or across or however to the well or to the reservoir. I keep making that mistake. I am so sorry. You drill down to the reservoir, and if you just pump, you can get 30 to 40% of the oil within that reservoir. And as you might imagine, initially you get a whole lot and then it reduces over time. If you want to get more out, you have to do this thing called enhanced oil recovery. In that case, you are forcing something else into the reservoir, carbon dioxide, steam, or some sort of chemical, which then makes it easier to pump out the oil within the well. Oil within the reservoir. I'm going to try. Here is an example of how you would do the forced pumping. You have an injection well off to the side of the reservoir that pumps, in this case, carbon dioxide over towards the producing wells. Here is another thing that happens. For example, if you're drilling into the Barnett Shale to get the oil out of that reservoir, you can actually fracture the shale. There is a region underneath the shale where it does not fracture. It's a different type of material. The fracture occurs because of the material being forced into the well. Okay, so you find a reservoir. You can then estimate how much oil is in there. These result in the estimated reserves. You're guessing about how big the location is, how much is down there. Proven reserves are the amount that you can economically remove from a located deposit. And actual production is what you withdraw from the deposit. We have about 4 trillion barrels of oil remaining. We have already consumed over 465 billion. Our current consumption rate is 90 million barrels per day, and we have proven reserves of about 1.6 trillion barrels, or less than 50 years of consumption remaining. That's as of 2013. Here is a map. It's actually the same one we saw in Unit 3 of where the oil or the deposits are. For petroleum and natural gas, they're red and red striped. You can see there's a bunch in the Rocky Mountain area and the kind of southwest Texas, Oklahoma area in the United States. There are some in northern Africa and some on western Africa, a bit in South America, and a fair bit up in Europe and Asia. Here is a map showing where is tectonically active. You might remember this as the Ring of Fire from previous studies. The red dots are a gas field, one in Western Europe. Yes, Western Europe. One down here kind of in the Egypt area of Africa, a couple down in Australia, and one over at the top of South America. There are also oil fields. There's a big one in the Gulf of Mexico, which probably is no surprise, one off of the west coast of the United States, a couple down in Mexico, one in South America, a couple in Africa, and a couple in other locations. Notice sometimes there are numbers. Those numbers are how many wells are in that area, or number of fields. Sorry, not wells, fields. So, in the 1940s, a geophysicist by the name of Hubbert predicted a bell curve for U.S. oil production. He predicted that it would peak in the 1970s, and he was correct. At the peak, 1/2 of the total supply has been withdrawn. 1/2 has been used. It's now gone. World oil production follows the same curve. There are things that can alter the curve, like the discoveries of the Marcellus Shale in West Virginia and the Athabasca tar sands in Alberta. These were not traditionally looked at as sources, but are now. But remember, there are a lot of environmental impacts to getting the resources out of these locations. For the Marcellus Shale in West Virginia, it involves fracking. Are we going to accept fracking? Here are the Hubbert curves for global oil production. As you can see, most of them have already peaked in the year 2000, if not earlier. So, it's a dilemma. The primary source of energy for U.S. industry and transportation is oil. But we're not oil rich. And we have a bit of a drip, spill, and kill legacy. So where do we get our oil from? Now, this is slightly old because there are some new sources in the United States supplying us, but that's okay. The biggest supplier of oil to the United States is actually Canada, followed by what you would think of as Saudi Arabia over in the Middle East. Mexico is a big exporter to the United States, as is Venezuela, and the rest, they're small, but they're there. So where are they? This table is from your book, and it shows how many billions of barrels or trillion of cubic feet of oil and natural gas are available in different countries. Right? Also shows coal. Notice the United States, or North America, I guess, which includes Canada and Mexico, has the biggest coal reserve, with the exception of what's in Far East and Oceania, which is going to be hard to get to, and Eastern Europe has quite a bit. Compare that to the United States gas and oil reserves. 60 oil, as opposed to the max in the Middle East of almost 735. The same story with natural gas. It's all in the Middle East. Should have expected a picture of an oil platform. Not sure where this one is, but there it is. This one is off of the Gulf Coast. These are nearshore rigs in Louisiana. Here is another offshore rig.